Hello and welcome to Construction Tech, presented by Passive House Accelerator, a catalyst of zero carbon building. We're happy you're here. We welcome all comers to our exploration of how to slash the greenhouse gas emissions of our buildings and make them more resilient to the extreme temperatures, wild weather, and grid insecurity caused by climate change. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce this weekly series to dive into the details of Passive House construction practice, with a technical focus on technique and technology in the field. New to all of this, please visit the Passive House 101 section of our website to get started. With that, please enjoy Construction Tech and pose your questions in chat for the discussion session following the presentation. Thank you.
How fun is that? Welcome, everyone. Welcome to Construction Tech. Thanks for showing up this Tuesday. Every week we have our speakers and our sponsors and our co-hosts, but tonight we really want to thank our friends attending. You are an amazing, educated gang of beautiful nerds, and we're glad you're here. So if you're new, welcome. Open your chat window, prepare to find a friend. Our presenters will show their projects while everyone remains on mute and chats it up in the comments. And we'll invite you to unmute yourself and ask your questions at the end. So with that, I'm going to hand it off to Mark Willey. Mark, how was your week? You ready for the Fraley Street EnerPHit?
I am more than ready. I'm more than ready, Shannon, because I've got to see it. And I've got to watch the Instagram reel every minute of the day. You can just keep pressing it and it'll keep showing it over and over. It's amazing. So I encourage everyone tonight to ask a lot of questions, because if you put a cue right there, we will get to it later on. And if you have comments, there's things that interest you throughout, we want to know about that. We want to know what interests you, and we want to keep this going. For instance, if you want to know what Hans is drinking, say, hey, Hans, what are you drinking? I really am excited. Feel free to take screenshots, share them on Instagram, LinkedIn, and all those wonderful pages, and invite your friends to join us next week. Right now, microphone to Sean.
Good evening, everyone. I'm Sean St. Amour. Happy to be here. Happy that last week we were back to school at BCIT. And I'm just going to throw in a post and a link, because I don't think we got to posting the mock-ups and all the fun stuff that Graham Finch and James Roger, who created those videos with RDH. So check those out. Again, lots of great opportunities in the training world. So if you're looking to become a certified passive house tradesperson, reach out to all the different avenues, because we have BCIT, Passive House Canada. I know Louise is there. We have EMU, with the NAPHN, which is now the Passive House Network, and also FIAS training. So if you want to get educated, there's lots of good stuff. Now, I got the pleasure of meeting Norm a few years ago when I was at the Pittsburgh Passive House Conference, and he became quite a celebrity. 475 had him come to our booth, and he got to talk about a really cool project, which was the Refarm Cafe. And he literally made our booth like we were at a concert. There was about, we filled up the aisle and everyone was listening to Norm. And I got to realize, man, this guy knows his stuff. He gets it. He's passionate about it. And so I'm definitely honored to not only hear tonight's presentation, but have him out there, because this guy definitely knows his stuff. And so before I turn it over to Kevin, just want to give a shout out, because last week we didn't do this. We didn't give the shout out to our first responders, who unfortunately had the 20th anniversary of the tragedy in New York City. And so we're really lucky, because Kevin, who has a full-time job as being a firefighter, was there with his team, dealing with and joining his group in doing that. So to Kevin and the rest of the New York first aid attendants and responders, thank you for your service. Kevin, over to you, my friend.
Thanks, Sean. It's been it's a great, thank you very much for showing respect. And, you know, it's an amazing time here in New York City with the 20th anniversary of 9/11. You know, not only the first responder community that perished that day, but the people in the buildings. It's a great time to remember that those buildings came down because people didn't, you know, we were on their land and they had something against us. And a lot of it had to do with fossil fuel and oil. And we're here fighting the good fight up front, trying to stop that from happening. So we're doing the best we can on every project. And this Passive House community is a group of change agents. And I'm really proud to call someone like Norm a friend that I met at the Passive House conference in New York. And, you know, we got it off right away. We're talking about retrofits and using blower doors. So I'm excited about this presentation. And thanks, Sean, for those kind words. All right, Norm, you ready? Because I'm ready.
I think I am ready.
Excellent. Thank you, my friend.
All right. Everyone, my name is Norm Horn. I work with a company called Invinity in State College, Pennsylvania. We're a design build, renewable energy and mechanical engineering firm. I'm a certified Passive House consultant and tradesperson and the construction manager on the project we'll be talking about this evening. I also have with me here Gary Moshier of Moshier Studio in Pittsburgh, Pennsylvania. Gary is the lead architect and Passive House consultant on this job, and one of the teachers in the classes that I took to become a consultant. And you know, huge thanks to Sean and Kevin, Mark, Shannon, Zach, Michael, Sydney, the whole Accelerator crew and community for having us here tonight, and you know, for creating and maintaining forums like this for sharing knowledge and experience. It's great to be back. I missed being here every Tuesday through August. So it's good to see y'all back, and I'm glad to have you here to listen to us. So we're going to be talking about a masonry retrofit building tonight. It's a 3-story mid-block building going for the PHI EnerPHit standard. So this is a project currently under construction. We started about 2 years ago when the building owner's board of directors voted to renovate this 125-year-old building to the Passive House standard. Gary and I gave a version of this presentation at the NAPHN conference back in June. So for anyone who saw that, I apologize for any repetition, but I wanted to cover some of the same material tonight as some background, and then we'll take a look at a few details and problems and how we solve them. So where's Kane, Pennsylvania? Kane's a town of about 3,500 residents in the northwest corner of the state. We're about 2.5 hours from Pittsburgh, 2 hours from Erie, and 2 hours down to State College where I live. The name the wilds that you've seen on this project a couple of times comes from the Pennsylvania wilds, which is a 12.5 county conservation landscape that covers the north central part of Pennsylvania. So if you can see my cursor down here in the bottom right-hand corner, you can see the footprint of the 12.5 counties that make up the PA Wilds territory. It's a huge area. I mean, it accounts for almost 25% of the state's acreage, including over 2 million acres of public land. It's home to iconic American brands like Woolrich Clothing, Zippo Lighters, Straw Beer, but only 4% of the state's population. So Kane is squarely in the middle of the Allegheny National Forest, which is the former hardwood lumber, specifically black cherry capital of the world. Forestry and logging are still a huge part of the regional economy, but now joined by thriving outdoor recreation and tourism activities. So I'm going to hand it over to Gary here for a few minutes, and he's going to talk about the site, the context, and his design response to this problem.
Sure. Thanks, Norm. Welcome, everyone. Yeah, so downtown Kane is situated right along US Route 6. Kane was founded in the 1860s, built up around the turn of the 20th century. So there's a lot of Victorian, Georgian revival, neoclassical, or Edwardian architecture. An awful lot of brick. There's clay in that area. In fact, the soil in most of Western Pennsylvania is clay. So there's a lot of brick architecture here. Kane's a pretty typical town in this part of the country with a brick building main street, a lot of good brickwork. So this is the view of the buildings across the street from our place. And you can see there's a variety of qualities of original work, qualities of preservation, reconstruction, and so forth. So just go to the next one there, Norm. Okay. Yeah, so here's a little bit more. You can see some of the variety of construction, 2 and 3 story buildings, some painted, some left natural. Some have been, they've had the dental work and so forth, nicely restored. So it's kind of a mixed bag, but generally a nice context of nice brick and stone buildings. In these 2 photos, you can see these are historic photos. The one on the left, where the big green arrow is, that's our building somewhere around the turn of the century. The buildings on either side were erected around 1900. Our building was built in about like 1898. So you can see a nice little 2-story building there. Then in the drawing on the photo on the right, this is a photo from the 60s. And you can see that at this point, at some point, we gained a 3rd floor and also lost a lot of the nice detail off the front of the building. So there was what we call permastone put on the front. Today we call it lick and stick. But it was, again, pretty typical of what was done to buildings in the 50s. And so that's the context that we started with here, is this 3-story building. So there's a little bit of a play between our building and neighboring buildings, and we've got a little some diagrams here that explain that. So here's our building. It's built as a 2-story, standalone, nothing on either side. And a few years later, along come the buildings on the north and south. And what they did is they used our party walls to attach to their wood frame interiors. And then they were 3-story buildings. They basically built their bearing walls right on top of our party walls. Again, fairly typical of downtown construction in this part of the country. So so that was in 1900, and then 1928 or so, the owners of our building decided to add the 3rd floor. So they just threw some nice big steel beams across between the party walls, added a roof structure to the top. And all of a sudden we have 3 extremely interconnected buildings. And so this, as you can imagine, is going to show up later as some challenges for us as we try to make this building a little bit more airtight and a little more independent. So the basic design concept here is we have a long, skinny building. We have windows on the east, windows on the west. Great orientation here. We got our long axis east-west. The only problem is we have no exposure on the south. So our party walls are north and south. Open walls are east and west. And on top of that, we've got about a 40-foot wide building that was originally built as 2 spans with wood frame construction. And as most folks in our business know, you can't span 20 feet with a 2x12 and carry 100 pounds a square foot that you need for modern building codes. So first thing we did was we shortened the span down to 3. We added rows of columns down through at the 3rd points. Took us down to 12-foot spans, 12 to 13-foot spans. And then we also put all the services along the south wall. We have an elevator and a stair tower. It's actually shared with the building next door, which is actually the building Norm's sitting in right now. And so we are now sort of sharing an elevator with that building next door. So that's the basic concept. Took that up 3 floors. We only took the columns up to the basement 1st and 2nd. 3rd floor is, as I said, the roof is a clear span, so there was no need to take the columns through. So we have a nice open clear span space on the 3rd floor. If you go to the sections there, Norm, we can look at it. So here you can see in section, we have a partial basement, full 1st floor, full 2nd floor, full 3rd floor. You can see the new roof structure we put on here. Norm will get into some great detail on that later. Got the stairway up the front, and nice big open roof, good for mechanical equipment and solar panels. And then as far as the envelope, you can see we've got the big party walls. We'll just have a little bit of wall on the south wall, the south elevation that's free of the building next door. A little bit more on the north wall, but our primary elevations are east and west. The east side was a total write-off as far as brick integrity, so we ripped it off and we put on this nice new sandstone facade on the front, locally quarried sandstone with a brick with a steel frame backup. on the back side, we basically just clad the back. We're going to clad the back brick with insulation and metal siding. Got a little rendering here of the front view. Again, we're planning to put in some sandstone on the front. It's from a quarry about 120 miles away, not even, about 90 miles away, and Russell Stone Quarry. And this is all on thermally broken clips back to the steel structure. Nice big curtain walls. They're on the boat from Germany as we speak, and so that's basically our response to the street and to the building. So I'll let Norm take it from here and tell us a little bit about what the building was like when he took it over and where we're going with it.
Great, thanks, Gary. So here we were last summer. We've got started. You can see pretty clearly here this line where our second floor started and the third floor was popped up. So, when I first, this is the very first day that I stepped onto the site, and I think it's safe to say that 125 years in, this structure needs some real help, whether we were doing passive house or not. Most pressing problems were a leaking center drained roof that had failed in numerous places, and as Gary mentioned, that brick facade that was pulling away from its neighbors. But take a look at the interior space. This is the third floor where we have 14 feet to the bottom of these big steel I-beams that make a 37-foot clear span. So it was like a wide open football field in the third floor. It's amazing. So the first thing that we did after construction reopened in the spring of 2020 was to remove the front facade and the wood portion of the roof. Like I said, we wanted to get started with this in the spring of 2020, but we know how that ended. So we're left with starting in August and trying to get both of these assemblies removed, replaced, tied in and dried in by the middle of October, when snow is a real possibility here in the northern part of Pennsylvania. So we worked on both of these assemblies concurrently. We did some temporary support and weather protection on the front. The masons came in and took down this load-bearing 3-wife brick facade. So here you can see the 2 floor planes sticking out and the roof sort of temporarily supported up there. And they kept going down below the sidewalk into this 2-foot thick sandstone foundation to establish these piers for the new steel facade backup structure to sit on. So for that structure, we worked with a local steel fab shop these guys really rose to the challenge on this project. The attention to detail and quality of work that they delivered on top of having to navigate, I don't know how many approvals from the municipality and PennDOT permits to transport the steel and then shut down Fraley Street, which is a state route and the main street through town for a day and a half for the crane set. I mean, that was an incredible effort, and to do it in a short amount of time was amazing. So they fabricated these 2 58-foot tall steel towers that were dropped into place and then connected the 2 of those towers together with just a few beams in the middle bay to complete the structure. So here you can see them setting the first tower on the left of the building and tying it back in. Here's the second one going in, and then finally the whole thing assembled. Oh, sorry, jumping ahead here. Here we are putting the beams in the center to tie them together, and then finally the whole thing assembled and tied back to the neighboring buildings at the end of the first day. While the steel was being set and fabricated, the carpenters were up on the roof, replacing that roof structure section by section. You probably saw a little glimpse of that in that aerial photo too there of the steel set. So remember from earlier, the third floor pop-up addition thing was supported by these giant 18-inch steel I-beams that were inserted into the parapets of our neighboring buildings. And the roof assembly and how it connects to the walls is where the discussion of air and thermal control layers is where it starts to get really fun, for me at least, because we wanted to use the roof deck as the air barrier, and also intended to keep as much, if not all, of our roof insulation outboard, so we could have high ceilings in there, right? So we removed all the roof rafters and little stud walls on top of those I-beams that made up that original middle drained roof, and replaced them with open web trusses that span the roughly 16 feet on center between the steel beams to get a monoslope roof. We left these lower ceiling joists in as a work platform, and then later salvaged those out to be reused elsewhere. So here we are with the first section of roof removed and the first new trusses going in. So these gable end trusses were sheathed with zip R sheathing, which gives us an air barrier and R9 insulation on one panel. And we taped the seams and the perimeter of each of these trusses from the outside as they went in, as well as then taping the trusses to the roof deck. And that gave us a continuous air barrier to connect to later with our inside party walls. There's a shot from below looking up through those old 2x8s into the new roof trusses. Here's a pic from the rear of the building looking forward after about, 4 of these sections had been removed and replaced. So if you take note of that little green arrow there on the bottom right, how that's pointing to the roof decking overhanging the parapets there, take a note of that. We'll come back to that later when we get a few slides in here. So here we are. This is the day before the steel set. We took off that last section to get it out of the way. And here we are a day later after that with the steel tied in and completed. So then once the new facade and roof structures were in place, we were able to start in on the roof insulation and membrane. And we went with a white TPO membrane, which with the thought that the extra reflectivity would benefit our solar array, which is scheduled to be 102 435 watt LG bifacial panels. That's modeled to generate about 51,000 kilowatt hours per year. And Gary was able to get the PHPP to work with a continuous 8 inches of polyiso across the roof deck. So that meant that we didn't need to do anything additional inside the building. So these two show how those layers went together. So each layer of our roof buildup, starting with AVB at the bottom, 2 layers of 4-inch polyiso, a layer of tapered polyiso at the edge, coverboard, membrane. All of this was adhered to the previous layer with calf grip adhesive to eliminate any mechanical penetrations in the roof deck and maintain the integrity of that air barrier. Here's a clip from Gary's CD set that shows that roof deck overhanging the parapets that I pointed out earlier. So what that detail allowed us to do was to create an insulated cap or a lid that landed on top of the parapets instead of having a roof that fit down in between them. So maybe noticing a theme here of building on top of other buildings' parapets. There's a little sketch diagram, shows that maybe a little bit clearer how the polyiso fills the spaces between the old parapet and the new deck, and how the air barrier connects down from the roof deck across the gable and across the gable end trusses, and then eventually gets taped into the interior brick surface. Here it is in reality. The guys packing that top of that parapet space with a foot or so of polyiso, and a wider view of them working their way down. Finally, this is the clean transition that we wound up with to our neighbors' roofs with no need for parapet caps, coping, or any kind of membrane gymnastics. Here's another view from the south side, nice and straight and clean on both sides. So now we got all those done. We missed the snow. We made that first cutoff. We had to move to tying all this stuff together. And those two assemblies, the roof and the facade, accounted for about 40% of the total envelope area. The strategy here was really very simple. Using the roof deck as an air barrier, the first floor deck, the backside of this steel frame backup wall in the front, and the existing masonry party walls and exterior walls at the rear for the air barrier. So we don't have any large areas of membranes or sheets here, but we did use gallons and gallons and gallons of Proclima Viscon fluid applied vapor control air barrier product extensively to treat those masonry walls. So with anything like this, the large open areas are pretty easy, but the challenge and the money is always in the corners and the intersections. So we'll start with taking a look at some of the easier ones here. So roof deck, we just talked about this. Our first floor deck is essentially the same thing, 3/4 inch Advantech with taped seams, and then connected the walls at the corners with tape and or fluid. The steel frame on the facade, the structural steel armature was infilled with 16 gauge studs and rock wool, then sheathed on the exterior with 5/8 zip for our WRB, and then the green 7/16 zip on the inside for the air barrier. It's pretty simple, except for the joints to the existing brick, where we had to carefully, tape those into all the joints in the corners there. And so the masonry party walls were, and the remaining exterior walls are a big part of the picture here. And one of the earliest things that we did on site was trying to identify and repair all the obvious problems. So we had over 12,000 square feet of multiple white brick walls to air seal, which included 600 2x8 penetrations, 2x12 joist penetrations, numerous abandoned chimneys, flues, mechanical penetrations, straight up holes, and just thousands and thousands of linear feet of these little nailer strips between the bed joints of about every 7th or 8th course of the walls. So an important part of the program here was the owner's desire to show as much interior brick as possible in these finished spaces, even if it had to be coated with an air barrier product and then painted. So we had to be conscious of where we could get away with parging or infilling with CMU, and where we had to be more careful with cleaning, repointing, and infilling with brick, and trying to tie things in a little bit neater. So one thing that really helped us to quickly get back into the game after the COVID shutdown ended were the set of masonry repair drawings that Gary and his office prepared. So these helped break all that square footage and multiple conditions down into manageable chunks of work that could easily guide the masons through which treatments needed to happen where. So, the numerous challenges inherent in a masonry retrofit, pocketed floor joists are high on the list of problems to solve. And, something we've talked about here, numerous times on Tuesday nights. We spent a lot of time going through this space joist by joist, cleaning up old mortar blobs, pulling nails, tucking and parging around each penetration. Unfortunately, there's just no fast, easy, one-size-fits-all solution for that job. And these are some of the nicer ones that we dealt with. These are some of the less nice ones. So again, back to the original sequence of things, making for some interesting details. So the second floor ceiling, used to be the roof. So it's framed with a double 2x8 cockloft assembly, where only the bottom 2x8s were pocketed into the masonry, and then the top members were stood off of them with 1x6s, and those top 2x8s stopped short of the party walls. Here you can see that probably about a 3/4 inch gap between the end of the upper 2x8 and the brick. Our masons spent a lot of time and effort going around the perimeter of this building at the floor intersection, and parging, tucking around all of these joists, and making sure that we were airtight in the areas that we'd be covering up later. Sometimes this involved working from above, sometimes it involved working from below to make sure that you got everything. And after a few days of this, we determined that the way more humane approach for the masons was to cut back that top member to give them a little bit more room to get a full trowel mortar in there. So, working with the masons, determining the proper amount of effort to put into chasing holes, cracks, and joints, and who was supposed to be doing what. That was a big part of developing our process for air sealing and getting everyone trained up for a new task. Because, one thing I didn't mention earlier is really nobody on site had any previous experience with Passive House except for me. And it's debatable as to how deep into Passive House I was at that point. So we had a lot of places like these nailer strips that I showed earlier that were straightforward and easy to repoint because they're like any other bed joint. Likewise, we had an untold number of pinholes, hairline cracks that we could safely rely on a fluid applied product to fill. We also had countless places that fell in the middle, too big for one approach, too small for another, joints between dissimilar materials. And in the end, it just boiled down to taking a methodical approach, paying close attention to details, and keeping track of what's been done and what's not been done. And when it came to the fluid applied products, we found the best people for that task were the paint crew, because they already owned the equipment. They're used to being meticulous about prep, finish quality, and keeping an eye on coverage. After cleaning, repointing, cleaning again, we sprayed and back rolled 2 coats of Viscon on all of the interior walls, and then touched up any last problem areas with Viscon fiber. So we ended up taking that process straight into the first coat of finish paint at that point for the sake of keeping the place clean. Since anyone who's worked with Viscon knows it's kind of like flypaper forever, but you can paint over it. So Renee and Jamie here worked with the carpenters who spent a lot of time either with a grout bag full of Viscon fiber or a bulk caulking gun full of that, chasing any of the visible holes that the masons couldn't get. So with a couple of good, reasonably short explanations of the why behind the task, everyone was able to work together and deliver some really solid results. This is Mark. He's our lead carpenter. He's doing a careful visual hairline crack and pinhole search around all these floor joists. And then one of the things we had to do here with some of these doubled up joists was drilled a hole in between them and then injected that hole with a sealant just to sort of head off that air leak between the joists, so we didn't have to chase that the whole way back and around. So here we are with the completed air sealed brick wall after a couple of weeks of working at this. In addition to being our air barrier, this treatment serves another important job of reflecting natural light back into the middle of the building. Like Gary said, at 125 feet long and oriented exactly east-west, we needed all the help we could get with reflectivity to get natural light back into the center of the space. So after finally getting the majority of all this brick coated, tying all the walls and floors together, buttoning up, the relatively few mechanical penetrations that we had, we're finally able to do some intermediate blower door tests, and they were admittedly rough, but this point of the game, I need to be able to show people who are working on this project what air leakage actually looks like, and that would give them the knowledge to know what they're looking for and what to do, to either fix it or avoid it in the first place. Because up until now, they're basically relying on me saying, yeah, there's going to be an air leak there. Just trust me on this. I'll show you this one day. I'm not making this up, right? So we also needed to start covering things up, and just to keep construction moving forward. And we couldn't bury leaks that we wouldn't be able to get to later. But doing blower door testing is pretty tough when you don't have windows and over 1,000 square feet of your envelope area is covered in reinforced plastic and painter's tape. So, last year when we started the construction and the PHPP numbers had settled out to roughly where they were going to stay, we figured that the estimated leakage area for our building volume was about 290 square inches if we hit the 1 ACH50 EnerPHit threshold. So the visual that I was using to explain that to the crew was that works out to the cumulative open area of about 3 8.5 by 11 sheets of paper. So this is my first masonry building to air seal. So I didn't really have a good frame of reference for how difficult 1 ACH50 would be to hit. I know what that looks like in a new wood framed building, but then our certifier mentioned that he thought that 0.3 ACH50 was going to be easily achievable, which frankly terrified me because I'm sitting here thinking of this whole thing in terms of sheets of paper, and our cutoff just went down from 3 sheets to 1 sheet. But it turns out, all the effort was totally worth it. And even with this plastic on the open areas and some pretty gaping gaps here and there, we were able to hit 1.3 ACH50. So we're at 4 sheets of paper, which I think is pretty good without having windows or curtain wall or doors, right? And we haven't been able to do any more tests since the spring, but we do have windows in the punched openings, and we could take a little bit of time to talk about that and how we handled those details. So here we are with the rear of the building during interior demo. Much like the interior, it had all the same problems. Numerous conditions that needed to be repaired or eliminated, glass block openings, pasted on covered staircase, back porch thing, thousands of legacy bolts, hangers, fasteners, 2-hole straps, and just damage from years of neglect. The plan for the exterior is to cover it in, we're doing 8 inches of insulation out there in most cases, and then we're going to install a metal panel system on thermally broken clips and rails. So that made it pretty easy for the masons on this one. They could just go through and hit things with mortar, much like they did inside, but a lot faster. The question that we had to solve though was how to install new windows in these old rough openings. And Gary came up with a modified approach to the classic passive house solution of adding an installation buck. But here we did it with Armatherm structural foam instead of plywood. There's a shot of one of the bucks being fitted into one of these ROs once we got it cleaned up. Here's a quick section from the CD set through that jam condition. Shows what Gary came up with. So this is through a side jam. What he did here is he added a little fin that gets you the over insulation on the jam and the head. That gives us a place to fasten the return piece of metal, as well as to terminate our insulation into. And on the inside, then it gives us a place to press our window frame and get a good positive seal right there against the weather. And here's the same condition through the head and sill. Head on the left, very similar to the jams. Sill on the right. Obviously, we don't have that fin. We have the window sits up on a little riser block that lets us get sloped down to our sill pan there. And just like the inside, we had the masons take care of the big holes, and the painters came back, followed behind them with the fluid applied product. In this case, we're using the Proseco R-Guard system as our WRB on the outside. Once Jamie and Renee got the base coat rolled on, we came back through with the thicker joint filling and flashing products, filled in any small areas of bare brick or mortar, and integrated the foam bucks into the WRB that we had on the walls. So finally, after several trips up and down around those windows, we got through all the steps. We're able to get our windows in, and these are Ventana UPVC triple pane tilt turns, made about 2 hours away, just outside of Pittsburgh, Pennsylvania. A little bit of reconfiguration left to do on the first floor, with turning doors into windows, adding some window openings, adding some bucks for louvers to our basement ERV. But we're finally all put back together now and weatherproofed on the rear elevations. We are at the end of last week. Proseco changed their formulation to Cat 5 while we were doing this project. So we started out with the pumpkin spice flavor and had to finish with gray. So with all the windows done on the outside, we taped them to the foam bucks, then taped the bucks to the brick on the inside, which completed our interior air barrier. So this little series just shows us hitting the Armatherm with a quick sand to get all the brick dust off, wipe down with some denatured, get a nice fresh clean surface to tape into. We'll detail of that corner, how those all came together. So finally, here are a few of the long views of what these interior spaces look like today. This is that third floor with those big I-beams that we saw way back at the beginning of the project. We've got all of our framing in. Guys are finishing up the elevator right there. Mechanicals are moving. It's all wired now. Ducting is all in. Here's the second floor, looking toward the rear of the windows that we just talked about, and turning 180, looking out the front. So all those areas of translucent plastic hopefully will be replaced with a triple pane timber curtain wall in about a month and a half here. So, to close up tonight, I want to make sure that we recognize, the people on the team who signed up to build a passive house, whether they knew what they were doing or not when they signed up. And that can include even, ownership at that level. And it's because of their vision that we can tell a story like this. In the time that I've been traveling to Kane, which is a little over a year now, I've seen builders, tradespeople who have been doing this for decades, along with Kane residents and stakeholders, have that aha moment and start to rethink how they think about energy efficiency in building. And education, outreach, and workforce development were key parts of the owner's program requirements. And we're seeing those goals being realized every day now. So our associate architect, Donna Zerkney of InScale Architects, just passed her CPHD exam and got her seal the other week. Our carpentry contractor that we saw earlier, Mark Luciano, he's getting ready to start the EMO trades course here in a few weeks. The Kane Chamber of Commerce, who's going to be one of our first floor tenants, has partnered with the Pittsburgh Children's Museum to build interactive exhibits to teach kids about energy efficiency and passive house, right here in the building. So despite all the frustrations that are inherent in any building and construction project, and especially when they're amplified by orders of magnitude over the last year and a half with COVID. You know, it's stories like this that that really make this work extra rewarding for me. So that's what I have to share for tonight. Thanks for all of your attention and your interest in the project, and I'll turn it back over to Shannon.
Bravo. Really great job, Gary. Really great job, Norm. And yes, what a team. I love the ending and the emphasis on workforce development, the fact that the whole community is involved. I know you have some friends from the community on the call, so we'll look forward to maybe in the after hour hearing from them a little bit, if they're willing to help us answer some questions about their part in the experience. But I love this project so much, Norm. I could watch it a couple times. I saw the presentation at Passive House for All, and it was just as engaging tonight. And what is your finish date? When do you think you'll close up? I know that's a mean question to ask, but
I don't know, is Joel on the line?
I mean, we had been early targeting November 1. I mean, that's obviously not going to happen for so many reasons. You know, part of that too is, you know, we added in full tenant fit out for 2 of these 3 floors to that scope. So, you know, we're thinking spring. You know, but it's always a roll of the dice, you know, when you're getting parts and pieces from the other side of the world. I mean, heck, even from, you know, a state away, it can be 12 to 15 weeks. So
I love how you source the steel locally and the windows locally, though, and the fact that so many people on the team are getting certified and that you're going to use it as a teaching tool. Really fantastic. I have some questions of my own, but I'll wait on those while we take a few from folks who have been waiting. Our first questions up are from Michael Ingui, Rob Hoskin, and John Burrell from Australia. I hope I'm saying your name right. Michael, would you like to unmute? Do you remember your question?
Yeah, thanks. You got my name right. Well, first of all, great project, and I also saw it at the Passive House conference. But so much has been done since then, and it looks really wonderful. I love it when I see sequencing, and that looks so simple and so easy and so obvious, like what you do with the roof. And I know it's not. What I wanted to know is just, you know, how did you get to that point? Because it really did look like kind of the obvious perfect choice and the way you handled that. And so is that something you guys developed in the field? Did you work that out before you started? You know, it was really clean. Nice work.
I guess I'll take that one. Yeah, we worked out ahead of time. I mean, we spent some time in the field. I mean, Norm and I, we spent a good solid couple of days just up there looking at the building, walking through it, climbing around. Then we were on the phone, on Teams calls, talking back and forth. So it was, and I sort of had an aha moment when I realized that we had to raise the roof elevation high enough to get single slope to the back, because we had to take all the water off the back. And that means I had to raise the front end pretty significantly. And in order to get it up far enough, I kept bumping into the parapets. And I realized that the only way I was going to get the roof off the back was to pick up the front high enough that I didn't have to drop the backside. So once I did that, it sort of the solution kind of presented itself, and I realized, gee, if we just sort of wrap on top of the parapets instead of trying to work into them or build them up, that was going to be our best shot at simplifying really the what was otherwise a very complex situation. So
yeah, really clean detail, really nice. Thanks for sharing it. And I actually also really loved the simple diagram that you showed after all that. That was also
I mean, a lot of the detail of that was definitely a team effort, because I proposed one thing and then Norm came back and proposed something else. The whole insulating the gable end was kind of a team effort, and then how do we do the deck? And we had about 3 or 4 different designs. Amel, who's on the call, had a couple different ways, and I think we finally we were all tearing our hair out here trying to figure that out, but it finally worked.
Yeah, great work.
Thanks, Michael. Rob Hoskin, are you out there? Would you like to unmute and ask your question?
Hello, hey, great job, guys. very excited to see the progress on the project. And I just noted the documentation that you have here on this project, and I know that part of the team, including Joel, is like they're crazy about documentation, but you know, all the photos you have here too are good, and it seems like, you know, there's going to be plenty to show the certification body that, you know, the building complies. And I guess my question was like how you're gonna, what your plan is for submitting the documentation, and anything else about the air leakage and other QA QC like ventilation stuff, what your plans are for that.
I don't have any specific plans yet for how we do the photos. I want to sort of work that out with Tad, our certifier. And Tad has also been previewing this with Darmstadt, and they're pretty excited about the project too. So we've had to have a few questions that we've bounced off of them. So they've had a sneak peek at it. Yeah, Tad and I have been having a little chat here on the sidebar today about that when he saw your question come through. So yeah, all that's going to get included with certification. It's all part of what his review, and then the review on to PHI.
Cool.
Just to add,
I'll let Norm handle the question about air sealing.
As far as how we're documenting that?
Yeah, and I also wanted to throw in ventilation there too, because that's going to be part of it.
Yeah, I mean, I have hundreds of photos of like that little triptych of the window taping going together. I mean, I've got probably 100 of that same kind of thing, just putting the ERV onto the roof and into the curb, layer by layer of insulation. So, I mean, I've been diligent about that, like any kind of weird thermal place underneath the steel columns, for instance, underneath the slab in the elevator hoistway pit, all those things, you know, I've got that all documented. So that'll be a lovely task someday to go through all those photos and sort those out.
Yeah.
But I mean, it's, you know, I had kind of a taste of that in putting these presentations together.
And ventilation is probably the topic of a whole nother Construction Tech Tuesday. You know,
That's a whole other animal right there.
November.
Yeah,
We're going to book that for
Great.
November.
Yeah, we've got event. But the short answer is we have a Ventacity 3000 CFM ERV unit on the roof, ventilating the entire building.
Locally made, you know, US made.
US made. Yeah, actually, it was surprised the heck out of us. The contractor went to order, and it was actually in stock on the shelf, and they shipped it like within a week or two of the order. So it actually sat in the contractor's warehouse for a couple of weeks till they were ready to hoist it up.
Did you guys go with the integrated HVAC units in the unit?
No, we have the integrated controls with the Fujitsu, but we did not put any cooling coils into the unit. We went back and forth on it. It just didn't, in the end, it didn't seem to make that much sense to do it that way, because we've got within the one unit, we have three different occupancy types. So we've got sort of office retail on the first, office on the second, and assembly on the third. So given the differences of occupancy times and occupancy loads, we felt it was better to have the better responsiveness and diversity just by putting all the cooling into the recirc units.
Great. Before we go to another question, we have a nice tradition here. Sean, you want to tell Gary and Norm what it is if they don't already know? I think they do.
Yeah, so this is the time when we ask the presenters just pay some respects to a mentor in their life that they have learned from, because again, we've all figured things out and we've had people there guiding us along the way. We always want to make sure that we pay them respect. So Norm, is there someone that you'd like to, or you know, one or more that you'd like to say hello to and give them thanks tonight?
Yeah, I don't have any one person in particular, and you know, call this cheesy if you like. I don't care, but you know, I'm really inspired by this whole team here. Really, anyone who's willing to stand back and second guess the way they've been doing things for decades, and you know, switch it up midstream. I mean, that to me that's amazing right there. That's inspiring. Anyone who's willing to do that to me is that's great in my book.
Gary, do you have a mentor?
I'm kind of in the same boat. I don't really have any one person. I've worked with folks sort of side by side for years. Looking at, I guess I've always sort of had a respect for the environment and a respect for history. We've done a lot of renovations of. My wife and I have our firm together here, and a few years ago we said most of our work is either old 100-year-old buildings that don't want to be renovated, or buildings in the middle of nowhere. So in Kane here, we have a building in the middle of nowhere that doesn't want to be renovated, and so it's kind of a nice sweet spot for where I've been going. But yeah, there've been folks along the line that I've learned from, but nothing sort of overarching. It's just always been alongside a bunch of people all the time. Guys like Norm. I see Gary Gardner on the line here. Rob, has been a good associate throughout the years, just, providing good sort of collegiality. And that's one thing I really love about the whole Passive House community, is just the collegial nature of it. It's been, it's really been great to be part of this community.
Great stuff, gentlemen.
Thanks, guys. If I could kindly just jump in at this moment, I wanted to call out one of my mentors on the 20th anniversary of 9/11. He is Lieutenant Nels Jorgensen, who is running a podcast called 20 for 20, bringing awareness of the stories of 9/11. So if you guys can see my screen, this is Lieutenant Nels there. He was my lieutenant at Ladder 80. He broke me in as a probie, and he was active during 9/11. So he's the real hero. I'm following the traditions and the footsteps of him and his father and the other guys that have been way before me. And I listened to this podcast. There's been 4 episodes so far. I listened to the one today about John Field and the fight that he fought in Congress to win World Trade Center, victims that come down with cancer, like Nels. Nels came down with cancer at the end of his career, and he tells the stories, gives back by doing a great job. And John Field's episode is phenomenal. And the reason I want to bring it to this community and bring Nels on is to bring awareness about 9/11 in the 20 years, but also to talk to the change agents tomorrow, which you guys are, that are fighting the forefront in the built environment, to let other people know, like, this is why we do what we do. So LT, you there? You can unmute yourself and just give a quick synopsis if you want. Oops, that's the wrong one.
I'm here now, Kev. I'm actually going to switch to the phone. I'm having a little bit of a satellite connection problem. I'm out here in Tennessee in the middle of nowhere, so just bear with me 1 second. Hopefully, can you hear me?
Yeah, we can hear you.
And while you get it together, can we give you a round of applause? Thank you so much.
Cheers, Nels.
Thank you, guys. It's my pleasure, and you have to pardon my my studio here. I'm a little bit new at this, so it's very, very rewarding right now to see a man like Kevin, who I had the pleasure of training and breaking in, and to see that he's moved on to being a senior firefighter who's making a difference out there and teaching guys. I'm grabbing some feedback. I don't know if it might coming in clear to you guys.
Lou, we're hearing an echo. You might have two screens open. So if you want to mute your computer mic.
I'm going to drop that other one in, Kev. Yep.
Got you.
Okay. How about now?
Perfect.
Oh, that's great.
All right, Kev. I apologize, guys. I want pencils and typewriters back. I'm an old guy. So anyway, such an honor. It warms my heart as a lieutenant, because most of what we do is we train the new guys, the young guys. And I've been moved on from the department now for 10 years. And 10 years ago, I had a fight for my life. I had a technically incurable leukemia that I'm a little get choked up sometimes. I really shouldn't be here talking to you. And now I'm still here. And sometimes I wonder why. Just recently, I think I got that answered. I'm on a mission to help. And Kevin was one of those guys when my family was just so caught up in back and forth to the hospital and this and that. I don't know if you guys know this, I might get him in trouble, but he's quite a chef. And my 21-year-old son just said to me recently, he goes, Dad, I love Kevin's chicken. Is there any way we could go to Firehouse and sit in for dinner one night? I said, well, he's up in the Bronx now, but yeah, we'll take a ride up and we'll go see him. So he made a lasting impression on my family. I'm taking this blessing of life now and I'm trying to do some good. And I was recently asked to join a 9/11 tribute charity podcast. It's called 2420podcast.com, as Kevin was kind enough to mention. And there's just a couple basic things we're trying to do with it. Take politics out of it, take all this other nonsense out of it. On 9/12/01, as sad as that event was the day before, the unity and the love and the cohesiveness of the people that were lined up along the West Side Highway for a mile leading down to the World Trade Center site. It was something I've never witnessed in my life. It was so beautiful. As sad as that day was, it was a beautiful, happy day because everybody, regardless of color, creed, race, this, that, whatever, hugging, loving, signs of encouragement. It was just a great time to be in this country. And we're not perfect, right? America's not perfect, but it's a damn good place. I've lived in Europe for a while and I couldn't wait to get back here. So we're trying to restore that feeling of 9/12 where we didn't yell at each other, we loved each other. And we're trying to bring some awareness to the Tunnel to Towers Foundation, which basically is this group of folks that's based around the brother of firefighter Stephen Siller. Stephen Siller was a brave man on the morning of 9/11. He was assigned to Squad Company 1. He was off duty, raced to the Battery Tunnel, and he parked his car. And he wasn't allowed to go through with his car because they were told it was going to be blown up. And he grabbed his fire gear and he ran 2.5 miles to get to the site. And he got there and he tried to find his company to work alongside them. And he was killed. And he was killed 50 yards away from my childhood best friend, John Sharp from Engine Company 201. 50 yards from them was my beloved Lieutenant, Dennis Oberg, who saved the on-duty crew of this hat and shirt that I'm wearing, Ladder 114. He saw something going wrong, and as construction folks, you would understand it. He saw the building starting to fail and disintegrate, and he turned his men around and said, run, don't look back, don't ask a question, run. And they did. And they dove under a truck. And 30, 40 yards behind them was this massive pile of what used to be two of the most beautiful structures in the world. And underneath the pile was his rookie son. And the senior man who I loved and adored from Ladder Company 105, who I was with in 1993 for the first bombing. And he said, kid, they didn't do it right. They blew it up in the middle. But if they did it in the corner, in a column, they would have dropped this thing down to Canal Street. That gentleman's name's Hank Miller, and he died alongside that rookie firefighter, Dennis Oberg. So I don't want to go on too long and take up your time because I know you guys are, you're conducting what you do. And if I would have known how much building knowledge Kevin had, I would have had him do all of our building inspection reports. But Kev, you got away easy, pal. But anyway,
thank you very much.
Honor just to be here. No, you're a good man, Kevin. You're a good man. But I'm just honored to be here. I'm flattered. I really appreciate the opportunity. This is new to me. As you could see, my studio that's bouncing around in my hand, right? It's we do a better job on the podcast. We actually have a little setup for that. But that being said, if you can tune in, if you can give it a listen, there's some really great stories of great people. And these people, they gave their lives that day for strangers. And the human acts of kindness are just incredible. And, if we can just bring back some of that love and that kindness and that empathy for each other, man, it would be such a better world right now. So that's my new mission, I guess, is to pay it back and pay it forward and basically say, hey, don't forget, try to send some love and just let us do good. So if you can tune in to 20for20.com, 20for20podcast.com. Really appreciate it. It's 100% charity. It's 100% going to good people. And I'm really honored and blessed to be involved with it. So thanks, folks, for your time, and appreciate it if you do listen and you like it. If you could just pass it on to 5 people, because we have no advertising, no budget. We're just strictly word of mouth and friends and family. So stay safe. Thanks for what you do. And God bless you and God bless America. And Kev, thank you, my friend.
Thanks, Lou.
Appreciate it.
Honor to have you on, and just the way you tell stories and the way you tell the stories and go through the podcast, it's phenomenal. So everyone will enjoy it. Just wanted to share with our community what the other side of my life is like, working with great people like.
Thank you, Lieutenant. Thank you
Oh,
so
right
much.
back.
And now we know where to go for
Thank you,
chicken.
ma'am. It's my
And
pleasure.
we put links to
Yes.
both of your podcast and the funds for your friend on our chat. So everybody's got access. Thank you for coming.
Thank you so much. And guys, you take care of yourself. Stay well and safe. Thanks again.
Fantastic. That's great.
Cheers.
Thanks. All right,
Cheers.
Zach, let's thank some sponsors.
Woo. Well, first of all, thank you for your work and the mission. It's really amazing. So on to a different note, I have other thank yous to make for the support of the Passive House Accelerator and the Construction Tech program. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsor is SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, Aero Barrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Innotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So tomorrow at the Global Passive House Showcase, we're really excited about this presentation by Michelle Apigian of Icon Architecture, Beverly Craig of Massachusetts Clean Energy Center, and Tom Chase of New Ecology. This is going to be about the Harbor Village Affordable Housing Project, which is a trailblazing project going on as part of the passive house boom underway in Massachusetts. So learn all about the design and construction of this really great building, as well as about the smart policies behind this passive house boom. And then next week on Construction Tech, we have something special. We're going to be learning about the Living Building project that's going on right now in Portland, Oregon. This is the new headquarters of PAE Engineers, and they've used passive design strategies to achieve Living Building certification, or at least that's on the docket. So we're going to learn about that from the construction team on Tuesday, and then actually on Wednesday we'll hear from the design team on the design side. So please join us next Tuesday. On the podcast, we have Mark Siddall of LEAP speaking from his work in the UK on passive house. He's one of the pioneers of passive house design and practice in the UK. Great conversation with co-host Matthew Cutler-Welsh. And then on Monday of next week, we have a passive house component spotlight. And this is going to be with Innotech, with Mike Cairns of Innotech. And they just announced a series of new PHI certified windows and doors that are manufactured in North America. So you won't want to miss learning about these new cool components that are available for your projects. Please join us on Monday for that presentation and for Q&A as well. Finally, Passive House Canada has its Tower Retrofit Symposium next week, September 22nd and 23rd. We're going to also be hosting a social, online social at the end of the day on September 22nd. So you can join us for that. There's a link there at the bottom to Passive House Canada's website and the Tower Retrofit URL. So don't miss that. And I forgot to say that I am about to chat everyone the link to register for Monday's Passive House Component Spotlight with Innotech Windows and Doors, 10 a.m. Pacific, 1 p.m. Eastern. Thank you.